Okay, I'm going to be working the homework here for 7.5. And the first question here asks us to find all 6 trig function values if this point, negative root 2 over 2, negative root 2 over 2 is on the unit circle. So basically we have the unit circle here, and we're at negative, 2 negative values, x and y. So that should put us at this common angle that we should be familiar with. And that's 180, right? This is 180, and then we add another 45. And so it's 225. And that's not important. What's important is the point here, the x and the y coordinate. So sine of t in this case will be the y coordinate. You know what? Let me just put these in. I can just, let me just put them in. So sine of t is just the y coordinate. So it's going to be the negative square root 2, negative square root of 2 over 2. Okay, cosine is the x coordinate, which is also negative square root of 2 over 2. Okay, and then tangent is the y coordinate divided by the x coordinate, but since they're the same, it's just going to be 1. And then the other 3 are just those flipped over. So cosecant would be, let's see if we'll take this, negative 2 over, negative 2 over the square root of 2. Good. Next one will be exactly the same, it's just flipping the cosine over, negative 2 over square root of 2. And finally, cotangent will be just 1 flipped over, which is 1. All right, next question. So find the value, find the 6 trig values here if the point square root of 55 over 8 and negative 3/8 is a point on the unit circle, it corresponds to the real number. Okay, so same thing. All we're going to do is, this is not a common point, but we can still do the same thing since it's on the unit circle. Sine of t will be the y coordinate, so negative 3 over 8. Excuse me. Hold on. Okay, so cosine will be the x coordinate, so it's just going to be square root of 55 over 8. Okay, now for the tangent, we might need to write this down. For tangent, it's the y coordinate divided by the x coordinate, but that's the same as the y coordinate times the reciprocal of the x coordinate. The 8's cancel and we get negative 3 over root 55. Let's go with that. Negative 3 divided by the square root of 55. Okay, and then now these are just all the others flipped over. So I'm going to go 8 over negative 3. That's tangent or sine flipped over. Then cosine flipped over. 8 over square root of 55. And finally, tangent flipped over. So I'm going to go square root of 55 over negative 3. Okay, so the point 4, negative 3 is on the circle, x squared plus y squared equals r squared. Is also on the terminal side of the angle in standard position. Find all 6 trig functions. So basically for this one, we're not on the unit circle this time. So we are basically on a circle with some radius. And the point we're looking at is the point 4, negative 3. So it's like we go out 4 and down 3. And we're here. So we want to know all 6 trig functions. So what we can use here, we can either do a triangle like this and label the sides, or we can just use the fact that this is the point 4, negative 3, and then find the radius. So forget the triangle, do the radius. And to get the radius, we use Pythagorean. So 4 squared plus negative 3 squared equals r squared. This is the one I'm going to use. This is 16 plus 9 equals r squared. That means 25 equals r squared, which means that r has to be the positive number 5. So we know that the x is 4 here, the y is -3, and the r is 5. And then from that, we can use the definition of all of these trig functions. So sine will always be y divided by r. So -3/5. The cosine will always be the x over the r, so 4/5. And tangent will always be the y divided by the x, which in this case would be -3 divided by 4. And then we just flip all these over. So -5/3 and 5/4. And tangent flipped over, so -4/3. All right. Same thing here. We have a point. The point is the point -1, 2. So here's our point. We need to find the radius. So I'm going to go -1 squared plus 2 squared equals r squared. So -1 squared is 1 plus 2 squared is 4. So r squared is 5. Take the square root, positive and negative, but because it's the radius, we always take the positive. So we have r is √5. So we have x is -1, y is 2, and r is √5. That's all we need. So the sine will be the y, which is 2, divided by r, which is there a way to do square root? No, maybe there is a way you can type it. Square root of 5. I hate having to click every time. It's kind of a pain. Okay, x over r, so -1 over square root of 5. Okay, let's see. Tangent will be the y divided by the x. That's just -2 over 1, which is -2. Cosecant is sine flipped, so square root of 5 over 2. Secant is cosine flipped, so square root of 5 over -1. You could just put negative square root of 5. That would be fine. Oh, what did I do? It didn't like that. That should have taken that. Let me do this. Negative square root of 5. That's messed up. It should have taken that. Okay, cotangent would be the reciprocal of tangent, so I'm going to put -1/2. There we go. All right, so now use the fact that the trigonometric functions are periodic to find the exact value. Don't use a calculator. So I'm going to just figure out what 405 degrees is. So if you think about 405 degrees, a full rotation is 360. So if I take 360 and subtract that, I'll get 45 degrees. So what's happening here is we're going all the way around, and then we're going an additional 45 degrees, which puts us here. That's a common angle. We know that. And we want sine. So if we go back to what we had memorized, this is √2 over 2, √2 over 2, right? If this angle here is 45, this angle right here, if that's 45, then that's √2 over 2, √2 over 2. So we know that sine of that would be just the y coordinate. So it would just be this, √2 over 2. And they want the exact answer here. So square root of 2 over 2. There we go. Okay, so now tangent of 390, same idea. So if we go, let's see again, 360 degrees, 390, take away 360, gives us 30 degrees. So we go all the way around, and then we go an additional 30 degrees here, and that's our angle. Now this point we have memorized. This one is √3 over 2, 1/2. And so tangent is the y divided by the x. So it's same as the y times the reciprocal of the x. And the 2's cancel. We should just get 1 over the square root of 3. 1 over square root of 3. Okay, same thing. So use the fact that trigonometric periodic, blah, 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 cosecant of 405. So cosecant of 405, let's see, 405, take away 360, it's 45. So we go around and we go around and we come back, go 45 degrees, same story. This is root 2 over 2, root 2 over 2. Tangent, or wait, cosecant right here is the reciprocal of sine. So sine is the y-coordinate. We want to do the reciprocal of that. So it should be, instead of root 2 over 2, it should be 2 over root 2. 2 over root 2. Okay. All right, so this one's a little different because we're given our angle in radians. So when we look at this 25 pi over 3, let's figure out how many rotations that is. So I'm going to subtract from that a full rotation, which is 2 pi. But to do this, I need to get a common denominator. So I multiply top and bottom here by 3. So 25 pi over 3 minus, let's see, 6 pi over 3. So if I do that, I get, let's see, 19 pi over 3. So that's like we've gone around one time. And look, if you look at 19 divided by 3, that's still bigger than 2. So I know I can subtract another 2 pi. Now, instead of me writing 2 pi and getting common denominator, I'm just going to write 6 pi over 3. So that way I don't have to get a common denominator. So I'm going to subtract a full rotation again. This time, let's see, 19 pi, take away 6 pi, should leave me 13 pi over 3. And now again, I can subtract another full rotation, 6 pi over 3. And this time I'll be left with 7 pi over 3. And then I can subtract another full rotation. And I'm finally left with pi over 3. Oh my gosh. Hold on, please. Okay, sorry about that. So let's see, how many rotations did we do here? We took away 2 pi there, so that was 1 rotation. Then we took away another one, that's 2, and then we took away another one, that's 3, another one, 4. So it's like we go around 1, 2, 3, 4, and then we still have a pi over 3. Pi over 3 is 60 degrees. So we're here, and that's 1/2 root 3 over 2. And we're looking for cosine, so it's the x coordinate, so it should just be 1/2. Okay, there we go. All right, so now we want to do tangent of 14 pi. Now this one I'm going to do a little bit different because it's a little easier to count pi's. So, well, you can just think about it this way. Every full rotation is 2 pi. So this would be 2, 4, 6, 8, 10, 12, 14 pi would take us around 7 times. So the important thing is we land on the x-axis. So we know that this point is the point 1, 0. And we want tangent. Tangent by definition is the y over the x. So it's 0 divided by 1, which is just 0. All right, 13 pi over 6. So we want cosecant of this. So 13 pi over 6. See, again, I'm going to look at this 13 over 6. That's bigger than 2. So I know I can subtract a 2 pi from this. That's a full rotation. So 13 pi over 6 minus common denominator here, 12 pi over 6. I'm just getting a 6 on top, 6 on bottom, so I have a common denominator. When I subtract there, I get pi over 6. So it's like I do a full rotation, and then I go just an additional pi over 6, which puts me here. That's root 3 over 2, 1/2. And I'm looking for cosecant, which is the reciprocal of sine. Sine is the y-coordinate, which is 1/2. So I flip 1/2 over, and I should just have 2. All right, 10 pi over 3, tangent of 10 pi over 3. Maybe I'm just going to do this one a different way just to show you some different methods here. 10 pi over 3. So I'm going to count by pi over 3s. How about that? So here's pi over 3, 60 degrees, all right? And 60 and 60, that gives you over here. Then 60 again, it's going to be 180. And then we're going to be here, then we're going to be here, then we're going to be back here. Okay, so those are our 60 multiples around the unit circle. And I need 10 of them. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which lands me right there. And that is something we should, again, we should know this off of the unit circle. This is going to be -1/2, negative √3 over 2. Now, let me show you that a different way. Let me just do the 10 pi over 3, and let's subtract 2 pi from that. And that's because 10 over 3 is bigger than 2, so I can do this. Get a common denominator. If I do that, I get 4 pi over 3, and that would be an angle that you should know. That would be 1 of these, 2 of these, 3 of these, and then 4 right there. So we would have found the same thing, okay, but just showing you 2 different ways of doing it. And now we want tangent. So tangent will be the y-coordinate divided by the x, which is the same as multiplying the reciprocal of the x. So I'm just taking -1 over 2, and I'm going to write it as 2 over -1. These cancel. And then I have negative over negative, which would be positive √3. So just square root of 3. All right. So use the even and odd properties. I have not covered this. So yeah, I had not covered this. So let me see what it says. Use the even and odd properties to find the exact value of the given expression. Do not use calculator. So yeah, this, I guess you could get the answer right now. I'll talk about what even and odd means in class. But basically, cosine is an even function. So if you plug a negative value into it, you get the same answer as if you plug in a positive value. That only works for cosine, all right, because it's what we call an even function. So if this number in here is a negative, then you get the same answer as if that number were positive. And cosine of 45 degrees, we know that at 45 degrees, cosine is going to be the x-coordinate, which is √2 over 2. So we should get √2 over 2. Select. So let's see, we're going to go here, and we're going to say it's square root of 2 divided by 2. Okay, so same thing, tangent of -30. So tangent is an odd function, which means that, oh, I gotta sneeze. Excuse me. Tangent of -30 degrees is not equal, it's not equal to tangent of 30 degrees. It's not like the cosine was. What it's equal to is negative of the tangent of 30. So we go to 30 degrees, which is here. We figure out what tangent is. Now this is √3 over 2, 1/2. Tangent would be the y-coordinate divided by the x-coordinate. And then we could do our flipping and stuff. And when we do that, we just get 1 over √3. And now what we do is we take that answer. Okay, so tangent of this is 1 over √3, and I'm going to just put a negative in front of it. So that should be it. So -1 over square root of 3. Okay. Okay, so secant is an even function, just like cosine was. So if I wanted to know what secant of 60 is, -60, all I really need to know is what is secant of 60 degrees. Okay, so secant of 60. So I go to 60, and that's going to be 1/2 √3 over 2. So secant, remember, is the reciprocal of cosine. So cosine is the x coordinate. So secant of 60 should be 1/2 flipped over, which is 2. And that should be the same as secant of negative 60 because it is an even function. All right, so sine is an odd function. So since sine is odd, that means that if we have sine of negative 180, this should be equal to not sine of 180, but negative sine of 180. So by this point, I hope you've caught on. Even means this: if you have a function and you plug in a value x, it's equal to plugging in the negative value. So like when we say cosine of negative 45, that should be equal to cosine of 45 degrees. So that's what it means to be even. To be odd means that when you take a function and you plug a negative into it, you don't get the same function with positive, you get negative of that function with the positive. So for example, if we do sine of negative 180, this should be sine of 180, positive 180, but make the answer negative. So that's what even and odd means. All right, so since sine is odd, this is what we have. Now we need to figure out what sine of 180 is. Well, that's pretty easy because 180 is right here, and that's the point negative 1, 0. And sine is the y coordinate, which is just 0. So this is just going to be negative 0, which is just 0. Okay, so 0. All right, clear this out. And I need to come back in just a second. Okay, here we have cotangent of negative pi over 3. Use the even and odd identities. And so cotangent is just a reciprocal of tangent. So since tangent is odd, we have that this will be odd. So we have that cotangent, oops, it's not cotangent. Cotangent of negative pi over 3 should be equal to the negative of cotangent of pi over 3. So let's go to pi over 3, 60 degrees. And then here the coordinates are 1/2 root 3 over 2. Now tangent is the y over the x. So here, since we're doing cotangent, it'll be the x over the y. And that's the same as the x multiplied by the reciprocal of the y. 2's cancel, we should just get 1 over, oops, I was thinking ahead here, that negative there. So this is actually positive, but we're going to move it up here and it's going to become negative 1 over root 3. All right, let's try that. Negative 1 over the square root of 3. All right. Okay, same thing. So sine is odd. So we know that sine of negative pi over 2 will be equal to negative sine of pi over 2. Okay, so at pi over 2, we're straight up here, and that's 0, 1. And the y coordinate there, since we're talking about sine, is 1, but then we're going to make it negative. So negative and then 1. We should get negative 1 here. So negative 1. And I should probably just take a quick moment to, let me see if I can do this. Let's see if I can bring up the ebook without losing the homework. I should probably just mention, you know, what the even and odd functions are. That way you know. Oh, where's that textbook? So here we go. All right, let's see if we can't find this. Domain range. I'm not sure how I missed this. Oh, we just didn't get to it. That was what it was. Periodic. even and odd properties. Okay, so it must have been the previous page. There we go. So here we go. Here are the even and odd properties. And so you can see it here that if you look at these, the ones that are even, the only even ones are these two. Okay, those are even. The rest are odd. So you can see if you plug in a negative to cosine, you get the same thing as cosine with a positive in it. If you plug in a negative to secant, you get the same things you get if you plug in a positive. These are a little different, right? So if you plug in a negative to sine, you get sine of theta, but you have to make that answer negative or change the sign. Okay, so the blue ones here are all odd, and that pinkish red is even. Okay, clear that out. Let's get back to the assignment, if I can find it. Here we go. All right, so cosine we know is odd. I'm sorry, even. So cosine of negative pi over 4 is the same as cosine of pi over 4. And that means we're here. Cosine is the x-coordinate, root 2 over 2. So that's all that matters to us. So this should just be square root of 2 divided by 2. There we go. I'm getting a little bit bored with this. Okay, secant of negative pi over 4 should be the same as secant of negative pi over 4 should be the same as secant of just pi over 4 because it's even. And pi over 4 here, we were just here. I should have just left it there. This is root 2 over 2. So cosine is root 2 over 2, and secant is a reciprocal, so it'd be 2 over root 2. So this should just be 2 over root 2. Okay. Cosecant. All right, so the difference here, we're still at the same angle. So let me put root 2 over 2 here. We're doing cosecant of negative pi over 4, which should be the same as negative cosecant of positive pi over 4. That's because it's odd. Now, cosecant of pi over 4 is just this y-coordinate, but flipped. So it'd be 2 over root 2, but then we have to put that negative in front. So we should get negative root 2, or negative 2 over root 2. Negative 2 over root 2. All right. So now something different, finally. Find the exact value of sine of negative 4 pi, cosine of 2 pi. So I'm going to do this by drawing a picture. So let's figure out what is sine. Let's do in red here. Let's do sine of negative 4 pi. So where is negative 4 pi? Well, we're going to go clockwise because it's a negative angle. We're going to go around. That's 2 pi, negative 2 pi. And then that's negative 4 pi. So we land here. And we know that that point is the point 1, 0. And we're looking for sine of that, which is the y-coordinate. So we know that that's 0. Plus, now let's do in blue, let's do, well, we'll do it in black, cosine of 2 pi. So 2 pi, we go all the way around one time, and cosine will be the x-coordinate, so that should just be 1. So our answer should just be 1. 0 plus 1 is 1. Okay, clear this out. So similar problem, let's see, we have, let's start with this red one, cosine of negative 2 pi. So we're going to go clockwise, 1 rotation. Cosine should be the x-coordinate, so that should be a 1. Plus, all right, cosecant of negative 3 pi over 2. I'm going to do this in blue. Okay, so cosecant of negative 3 pi over 2. So there's multiple ways to do this. I'm going to just figure out where that angle is. So we know that from here to here is positive 3 pi over 2. We want the same thing but negative. So we're going to go negative 3 pi over 2 puts us here. That's the point 0, 1. And then we want cosecant, which is the reciprocal of sine. Sine is the y-coordinate, which is 1. And so 1 over, if we flip 1 over, you just get 1. So this should also be 1. So 1 plus 1 should give us 2. And then this one here, clear. Ooh, okay, so for this one, how do we want to do this? There's a couple of ways to do it, but okay, so let's see here. Do I really want to? Let's figure out where 33 pi over 4 is. Let's do that. Let's just figure out, well, let's figure out where negative 33 pi over 4 is. So I'm going to write down negative 33 pi over 4. And I'm going to start adding full revolutions because this is a negative number. I'm going to start adding 2 pi until I get it to an angle I know. So I get a common denominator. So I need to multiply top and bottom by 4. And now I'm going to just start putting this together. So if I do that, I'm going to get negative 25 pi over 4. Let me add another full revolution to that. And when I do that, let's see, 8, I get 17, negative 17 pi over 4. Let me add another revolution to that. So I get negative 9 pi over 4, and let me add one more full revolution, and that would give me negative pi over 4. Oops, that's an equal sign. So I'm at negative pi over 4, which is negative angle right there. Okay, so that's where I am. Now, remember it's negative, so that's why I went this way. So negative pi over 4, the point here is going to be square root of 2 over 2 and negative root 2 over 2. All right, so let's figure out what is cosine of that angle. Cosine is the x-coordinate. So this whole thing should be just the x-coordinate. And then minus secant of that would be the reciprocal of the x-coordinate, which would be 2 over root 2, like that. Okay, so let's see if it takes this answer. We might have to simplify that, but I'm going to just try it. Square root of 2 over 2 minus 2 over square root of 2. Yeah. Didn't take it. All right, does it say? You know what, I just want to see, I don't want to have to go through this. What the heck? Okay, so let me try and clean this up. I'm pretty sure they're rationalizing the denominator. So what they do here is they take this one, they multiply root 2 over 2 here to get rid of the root on the bottom. So we have root 2 over 2, that's the first one, minus. Now we have 2 root 2 over 2, like that. Now if they have the same denominator, I can write that as root 2 minus 2 root 2 over 2. And so on this top one, look at it as being one of these, right? One of these roots minus 2 of those roots. So you should get negative 1 of those roots over 2. And that's what they wanted. Now, I would have accepted this answer on an exam, so don't worry about that. Okay, that should be it for this homework assignment.